Hello everyone, my name is Andrew Sangsai. Today I will present about smart circulating agriculture monitoring system based on bean sprout and Frass or back certified. For the outline, is including to the abstract, introduction and material and method, and result and discussion and conclusion. For the abstract, in conventional farming, farmers use the manual labor to handle crop and livestock, leading to inefficient resource use. Therefore, we design and develop a smart circulating agriculture system that implements the monitoring system, alerting system, and automation system. The system constantly collecting the sensor data on climate conditions, such as the temperature, humidity, and soil content, in order to increase both of quantity and quality of their product, and to ensure the immediate redress to event of the abnormal condition. As a result, the proposed system successfully control cultivating system. For the introduction, the traditional farming, the farmer used the manual labor to handle the crop and the livestock, leading to inefficient resource. And nowadays, current technology can improve the efficiency of the agricultural activities significantly, like the Internet of Things, artificial intelligence, and remote sensing, and etc. This platform aims to increase the production efficiency and increase quality, and minimize the environmental impact, which assists in providing a better growth rate for accurate crop product. And this present research, which is developed of smart greenhouse system, implement the monitoring, alerting, and automation system, and also including to the data analysis aspect of the greenhouse. For the next one will be the material and method. For the proposed system is architecture approach for implement the smart greenhouse with aspect monitoring, alerting, and automation system. In this figure is our smart greenhouse that including to the light and fan and water pump and also heater. And we also have the sensor inside the greenhouse to collect the data, just like the data from the temperature, humidity, and the soil content. The soil content that including to the soil NPK and soil pH and soil conductivity. Yeah. For the next one, it will be our proposed system architecture. For our work, we have two kinds of circuit board. The first one is the Raspberry Pi 4. And the second one is Arduino V-One. And we also use the MQTT broker to transmit data for each other. Yeah. For the Raspberry Pi 4, we separate into tasks for this circuit board. The first one is the database server, and the second one is Grafana dashboard. And then last one is automatic contouring, just like an automatic controllers. Temperature, humidity, and also automatic for feeding the water. For the database server, we use InfluxDB to be our database server, and for the dashboard system, we use Grafana to be our dashboard. And both of them is the open source. Yeah. And you can access from any device to our dashboard, and then you can see everything, just like the temperature, humidity, and another value from our greenhouse. And then you can also controlling from any device, and also you can see how it's going inside that. And for the next one, it will be Arduino V-One. For the Arduino, we will use it to connect to the sensor, just like the temperature sensor and humidity sensor, and also be the soil content sensor. And the next one will be our experimental setting for the controlling data. For our work, we have two kinds of the fertilizer. The first one is the Frass or back certified. The second one is a traditional fertilizer. For traditional fertilizer, just the normal fertilizer you can see in the market, or you just go to the plant shop, you can buy it. For the amount of fertilizer, we separate into 3 levels. The first one is no fertilizer, and the second one is the 1 gram fertilizer, and the last level will be 3 gram for the fertilizer. And for the temperature, we separate into 2 levels of the temperature. The first one is 25 degrees Celsius, and the second one will be 30 Celsius. And for the humidity, we also separate into two levels of the humidity. The first one will be 60%, and the second one will be 90%. So for this table, it will be just a part of our experimental testing. For the climate condition monitoring and alerting system, in the figure A, you will see the soil sensor that is used to measure about the soil NPK. Soil NPK is just like a soil nitrogen and soil phosphorus and soil potassium. And then for the soil sensor, we also have the soil pH, soil conductivity, or we call it soil EC. And then for the figure B, it is Arduino VMOS that we use to connect to the sensor to transmit the data to our database server. And the next figure will be our dashboard for the data system. For the dashboard, we have 2 axes. The first axis will be x-axis. X-axis it will show you about the time sequence, and for the y-axis it will show you about the level of the temperature. And the next figure it will show you about the humidity data system. This one also same as the last figure, but this one is just for the humidity. And you also see the x-axis and y-axis. X-axis it will show you about the time sequence, and the y-axis it will show you about the level of the humidity. The next figure it will be alerting to the user. We use line notify to let the user know about the condition inside the greenhouse, just like the temperature, humidity, nitrogen, phosphorus, potassium, and pH value and EC. For the irrigation and automation system, we have the automation system to control everything inside that, but depend on our condition for the experimental setting, just like in the table that we show you in the last slide. Yeah, for this one, it will show you our overview of monitoring system. For the left hand side, you will see the real-time value from the sensor and the sensor inside the greenhouse. And the middle one will be the bottom. The bottom is we use to control the fan, the light, and the heater, and the water pump. The next one will be the camera. The camera that we use to observe about the fan is that working, the light is working, and the heater or the pump is working or not. Yeah. And for the next one, it will be our overview of monitoring system on the smartphone platform. Yeah, you can access this one. You can access our dashboard from any device, Android, iOS, but we use it to be a web application, so we can use any web browser to access it, just like a Safari or Google Chrome. For the result and discussion, the smart circulating agriculture system presents multiple elements which are monitoring, alerting, and automation system, and implementing to a comprehensive IoT based on the smart circulating agriculture system can be deployed in greenhouse and farm alike. And this paper developed and implemented a system that continuously monitor and the climate condition, and it will alert to the farmer if the level is full or lies below on the ratio, and it can be turned on and turned off the actuators such as fan, water pump, heater, and the light accordingly. The last one will be our conclusion. The research paper has completely implemented a comprehensive IoT system based on a smart circulating agriculture system based on Beansprout and Frass or back certified. We supported the experimental setup with a combination of the monitoring, alerting, and automation, and it provides a suitable environment for Beansprout. In addition, the experiment was carried out easily, justify and the effect of the declared factor following. The first one is will be temperature, the second one is will be humidity, and the last one is the fertilizer. Okay, let me show you our system. The first one you can see, this one you will see on the web, on the laptop, that we use the Google Chrome to access, and another one we use the cell phone to connect it. And then we will show you about how it's working. Yeah, the first one, we can turn on and turn off the light here. Yeah, and then we turn off it. And then next one, we will turn on the fan. This one, the fan will be working like this. It will suck the air from inside to outside. Then I turn off it. And next one, I will turn on the water. This one. The water we use to feeding the water to our plant. Then I turn off it. And the last one, we have the heater because our work inside the lab. So since when we have someone to come to our lab, and then they open the air condition, so the temperature inside the greenhouse will be lower than the ratio. So we needed to make the weather is more stable. Yeah. Then I turn on it like this. Okay, I turn off it. Yeah. Okay, thank you for attention.